In this lesson we're going to take a look at cube roots. In order to understand what a cube root is, we first need to understand what a perfect cube is. Perfect cubes take their names off of perfect squares. So last section we saw the perfect squares were what happened when you took a number and raised it to the second power, or you squared it. So for example, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25. And then on the flip side, then we saw, well, the square root of 1, we'll do the square root of 1 is equal to 1. The square root of 4 equals 2. The square root of 9 equals 3. And the square root of 16 equals 4. And the square root of 25 would equal 5. So in taking what I got for the perfect squares, the square root undid it and gave me back my base here, the 1, the 2, the 3, the 4, the 5. Okay. For cube roots, we're going to look at something very similar. Instead of squaring the initial numbers, we're going to raise them to the third power. Okay, so let's look at a couple of these. What you'll notice is 1 cubed means 1 times 1 times 1. In this case it equals 1. 2 cubed would be 2 times 2 times 2, which equals 8. 3 cubed would be 3 times 3 times 3, which equals 27. 4 cubed is 4 times 4 times 4, which equals 64. And 5 cubed equals 5 times 5 times 5, which equals 125. So now, if I want to know what the cube root is, and the cube root, if this is the squared root, there's what's called an index of 2 that's ordinarily not written. It's understood to be the square root because it's the most commonly used. For a cube root, we use the same radical symbol, but instead, so to differentiate from the square root, we put an index of 3 right in the front. So what I would say is the cube root of 1 would equal 1. The cube root of 8 would equal 2. The cube root of 27 would equal 3. The cube root of 64 would equal 4. The cube root of 125 would equal 5. Now one thing to keep in mind with this is I could never take the square root of a negative number because no number times itself would ever give me a negative value. For cube roots, it is going to be possible to come up with this cube root of negative 8. In this case, it's going to be negative 2. The reason being is because if I asked you what number raised to the third power equals negative 8, x would end up equaling negative 2. Reason being, negative 2 times negative 2 times negative 2 would equal negative 8. So x would equal negative 2, or the cube root of negative 8 would equal negative 2. Okay. So just keep a mindset with this, that there is no such thing as the positive or negative cube root of a number. It's the cube root the sign of the cube root will actually be given by the value underneath the cube root sign. With perfect squares, we looked at a square model and said, well, if the length of the side is 4, okay, if this is a square, the area would be 16. Okay, because 4 times 4 would give me 16. So it was based off of area for the perfect square. One way of looking at perfect cubes doesn't deal with area, but deals with cubes, adding 3 dimensions. So because raising something to the second power deals with the area of a square, okay, cubing, or raising to the third power, deals with the volume of a cube, because it's a side times a side times a side. It's a length times a width times a height. So because of that, if I want to know, okay, let's say I have a volume of 8. This would have to be 2, that would have to be 2, this would have to be 2. And because of that, if I think three-dimensionally, in terms of the number of blocks I would use, I would actually have 1 block, 2 block, 3 block, 4 block on top, another 5, 6, 7, and then an 8th block in the back corner. So basically I would have 2 levels of 4 blocks, which is why the volume would be 8 units cubed. Okay, so basically if I wanted to know then what the cube root of 8 is, say I had 8 blocks, I would know that the length of each side would need to be 2 units. Okay, which is kind of the application for this whole idea of taking the cube root, which is the inverse of raising something to the cubic power. And just one other detail, what happens if I'm dealing with a fraction? So what happens if I wanted to know what the cube root of 1/64 was? Well, what I would basically do is think, what is the cube root of 1? What is the cube root of 64? Cube root of 1 is 1. Cube root of 64 is 4. So my answer would be 1/4. And I could check this. What's 1/4 times 1/4 times 1/4? 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. So here, do I have what I had underneath the cube root? Yes, I do, so it checks. Okay. So good luck with this, and we'll work on some problems tomorrow, in addition to any problems that I might have given to you for tonight to do. Okay.